another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com, where you can find our entire back catalog of over 100 episodes on research computing, high-performance computing, and scientifics. Anything. I have again with us Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for your time.
Hey, Brock. Yeah, this is always great stuff. I always love to learn new random things of the people and projects that we run into on the internet. So with that, I don't think we really actually even have any announcements today. So why don't you just tell us what we got on tap for today?
Okay, so today we have two people from the, I think it's referred to as Deal.II project. So guys, why don't you go ahead and take a moment to introduce yourselves?
Yeah, so I'm Wolfgang Bangerth. I'm a professor at Colorado State, and some 20 years ago I was stubborn enough to not like the software choices that were out there and just decided to write my own, and that turned into a 20-year-long project that I still maintain. That's Deal.II.
And my name is Timo Heister. I'm an assistant professor in mathematical sciences at Clemson University in South Carolina. And I've been involved with the Deal.II project for a couple of years now, and became a maintainer when I did my postdoc together with Wolfgang.
So give us the elevator pitch. What is Deal.II?
Sure. So Deal.II is a member of the great lineage of software libraries that we've been doing in computational science. So think about that's something that starts with BLAS and LAPACK, and then linear algebra libraries came along like PETSI and Trillinos that were on this podcast before. And then sometime in the early 2000s, people started to build finite element libraries. So finite elements is something that we use typically to solve partial differential equations in continuum mechanics. So for, let's say, solid mechanics problems or for flow problems. And there's sort of a common set of tools that you need to have to build these sort of code. So you need to have meshes, for example. You need to have descriptions of what we call finite elements. You need to have linear and nonlinear solvers. And all of these sort of things is what we put into Deal.II. So I should say this. It's a library written in C++. It's got about 1 million lines of code. It's probably one of the bigger ones in this field. It's got a fairly sizable community of a few hundred people who use it. That's sort of the 30,000 feet view of Deal.II.
All right. So for those of us who are not in the field, give us a little more on, what are these finite element analysis things? What are partial differential equations, and why do we need software packages for them?
Okay, so partial differential equations describe things in physics, right? They describe relationships of functions and, for example, in forces and other kinds of things. And the finite element method is a way to solve these differential equations numerically on a computer. And the interesting thing about finite elements is that it's even in the name, it's finite element analysis, is that it has a very strong mathematical foundation.
So now you mentioned, or actually Wolfgang mentioned, a bunch of different numerical packages out there. Why are there different ones, and why do we have packages for these anyway? Why is it hard to write software like this?
Yes, it's and it's repetitive and redundant if everybody does it themselves, right? That's why we have these packages and had them since the 1950s in Fortran, right? So what we do in Deal.II is not redundant to what, let's say, Trillinos and PETSI do in the linear algebra realm, and it's not redundant to what, let's say, BLAS and LAPACK do for the dense linear algebra, right? They all built on top of each other, and I think what we as a community have just learned is that over the last 30 years, we built libraries at higher and higher levels, right? That we started with dense linear algebra, and then we started to build libraries for sparse linear algebra and for parallel linear algebra, and then people started to write libraries for partial differential equations, and now there's libraries for uncertainty quantification and these sort of things. So they built sort of a stack where you can describe problems at a higher and higher level. And of course, all of them are, let's say, their own speciality, their own special area of computational science, where you have to have specialized knowledge. So not everybody understands how exactly to implement, let's say, a GMRS iterative solver, and not everybody understands how to implement finite elements, and not everybody has to, because now we have all of these libraries that provide these sort of functionalities in a more or less generic way that people who are not specialists can use them.
So you've thrown around a lot of different things. You mentioned PDEs, but just walking around floors at places like supercomputing and stuff, people will normally think of finite element as FEA, and that means just structures calculations, end user codes that we're familiar with for structures calculations. Sounds like that's not really the case. Sounds like FEA is just a method to solving a specific set of equations?
Yeah, that's right. So the finite element method is a way to solve all kinds of partial differential equations. So it could be in fluid dynamics, it could be in solid mechanics, it could be geosciences, magnetohydrodynamics, any kind of multi-physics problems, nuclear physics, astrophysics, and I could go on and on. So all kinds of physical phenomena that can be described by these PDEs.
So give us a little bit of background. You're talking about well-developed libraries and code reusability. What prompted you to develop a new FEA software library? What's the history?
Yeah, so I started this when I was doing my diploma thesis, so that's something like a master's thesis in Germany in 1998. And at the time, a lot of these libraries that we have today, 18 years, 19 years later, they didn't exist, right? PETSI was just so invented. Blatz and LAPACK was there, but there were really not a lot of libraries for this out there. And a lot of research groups were sort of starting to get into this field and were writing their own software libraries. And in the group that I was in Heidelberg, in Germany, there were a couple libraries that were written by people who were really good mathematicians and maybe not such good software designers. And so I'm one of those people who grew up in the late 80s as a teenager, so I had access to computers from when I was 14 or 15. And I had spent a lot of time programming. So when I became a master's student or then a PhD student, I sort of had a background in software design, and I saw that the software libraries that are out there were not all that well designed because the people didn't have a background in it. And then I probably also was more stubborn than most others, and I decided, well, to hell with this. And I just decided I'll rewrite the functionality that was already there and put that into a software library that I could build and shape and form the way I wanted it to. And that turned out to be a really useful thing because at the time, like I said, there was nothing there that was, let's say the World Wide Web wasn't really there. So when we put this onto a website, because we could, so that was in 2000, we put it on a website because that's what everybody was doing at the time because websites were new. And it turned out that people actually liked that and downloaded it and started to use it. And so we built a whole community of people around this that now contains, a few dozen people who contribute code every quarter or so. And so it was a little bit of an accident of being too stubborn to use what was there and wanting to do it right, and then come up with a design that apparently seems to work even 20 years later.
So before we go too much further, I do want to ask, where did the name come from, Deal.II?
Yeah, so that you have to attribute that to somebody who was 26 or 27 at the time, maybe not the professional. So there was a library that was called Deal at the time. There was the differential equations analysis library. And that's the one that I replaced. And so we needed to come up with something that had a different name, but I liked the acronym Deal. So we wanted to make it Deal.II, and then we just needed to come up with a catchy way of doing it. So we say Deal and then a Roman 2 behind it. That's where that name comes from.
Gotcha. Okay. Well, let me ask another history question then too. So back